In a cluster of stars that all formed at the exact same time, astronomers kept finding a handful that looked millions of years too young. That shouldn't be possible. Inside a star cluster, every star formed from the same cloud of gas at roughly the same moment, which means astronomers can measure a cluster's age with real precision. Bigger, hotter, bluer stars burn through their fuel fast and die young, while smaller, cooler, redder stars last far longer. Plot every star's brightness against its color, and the stars neatly line up along a predictable curve that reveals the cluster's true age. That chart is called a Hertzsprung-Russell diagram, and the exact point where stars begin peeling away from that curve, called the turn-off point, is one of the most reliable age markers astronomers have for any cluster. But in the 1950s, astronomer Alan Sandage found something that broke the pattern in a cluster called M3, a small group of stars sitting exactly where hot, young, blue stars should be, despite the rest of the cluster being billions of years old, well past the point where stars like that should have already died. He called them blue stragglers, because they appeared to be stragglers left behind on the wrong side of stellar time. Sandage found around 20 such stars in M3 alone, a globular cluster roughly 34,000 light-years away, and the discovery initially struck other astronomers as such an unlikely fluke that some suspected a measurement error rather than a real population of stars. The leading explanation isn't that these stars are actually young, it's that they got a second life. In the crowded environment of a cluster, stars pass close to each other far more often than stars out in normal space do. Some blue stragglers likely formed when two smaller stars in a close binary system merged into one, combining their mass into a single, hotter, bluer star. Others may have simply pulled material off a still living companion star, refueling themselves with fresh hydrogen and effectively resetting part of their internal clock. In the packed core of a globular cluster, stellar densities can run thousands of times higher than in the Sun's neighborhood, making close encounters and mergers common enough, over billions of years, to plausibly explain the numbers actually observed. Blue stragglers aren't rare exceptions, they've now been found in the vast majority of globular and open clusters that astronomers have carefully surveyed. What started as a single unexplained anomaly in one cluster turned into a well-documented category of stars that gained a second youth, either through a stellar collision, a merger, or theft, proof that even a star's age isn't always a fixed, simple number. Subscribe for more mysteries the data eventually explained. Blue Straggler Mystery.